Wonderful.
Or however that happens. I don't really know.
Wonderful. That's fantastic. Well, maybe it was a good decision, switching back to regular algebra.
Yeah, it's like ridiculously easy though.
You know, I've gotten that same response from other students that have done it, that have gone from honors back to regular. All of them say the same thing. It's like unbelievably easy.
Yeah, it's like you go from being like the dumbest kid in the smart class to the smartest kid in the dumb class. I don't know.
That's funny because it reminds me. I have two boys, and I always used to ask them when they were young. I said, if you were going to go to a planet, would you rather go to a planet where you were the smartest person on the planet or the dumbest person? And the answer isn't all that obvious. As to, you know, different people would choose different things.
Yeah, it's funny. But, yeah, so that's good. We took a test, and my teacher was saying a lot of kids struggled on it. But I felt it was okay.
Okay. Good.
And I don't think it'll affect my grade. So I was wondering if, because as of this minute I'm not having a lot of super math problems right now, if instead of doing only Algebra 2 all the time, if I could get, or if you would have any recommendations for like a book of practice questions I could get?
For?
Like the ACT test?
Came to the right spot.
And we took a practice one, and I got an 11 out of 16 and a 10 out of 16 for geometry.
Okay. So you need a little geometry practice.
On that, yeah, and algebra pre-algebra.
When are you going to take the test?
Next year.
Next year? Okay.
Like a little premature to be worried about it.
Well, that's okay. I firmly believe that working on the ACT is an excellent way to improve one's math skills. So if you don't have anything specific to work on in class, this is definitely a good thing for us to do. And I have 8 tests that have been digitized into my computer, so I got tons of resource material. Now, if you're looking to, if you're looking to get something on your own that you can work on your own, go to Barnes and Noble. You can get the Kaplan book. There's a Barron's. There's a Princeton Review. There'll be all kinds of books that give you practice exams.
All right, excellent.
And any of them, I don't know that one is necessarily better than another. Probably the ones you would want to get would be different than what I have. What I have is McGraw-Hill and Kaplan. So if you're going to get one of your own, probably get something different, because we always will have this material on my computer to practice ACT stuff.
All right.
Okay. So you want to just take a practice test, or you want to go to just the geometry problems, or?
I don't know. I'm actually looking at my practice tests right now.
Okay.
And I have some problems I missed. Like, they gave us an answer key. I don't really know how to work this. There's a lot of, like, graphs and things I don't understand.
Okay.
Yeah, but the one thing I got circled on mine a lot was the geometry problem.
Okay.
And for whatever reason, pre-algebra.
Okay. Well, there's a couple of things we could do. We could specifically search out my practice tests for geometry questions and probably trig. How did you think you did on the 4 trig questions?
Probably not excellent.
Okay. I can definitely help you there, because you and I haven't done trig yet, but I can teach you the amount of trig you need to know to get all 4 questions right on the ACT. It's not hard trig, it's basic trig. So it wouldn't be that hard. So we can do this. We can either just start with question 1 and go down and do them all, or we can search through rather rapidly to where we find geometry problems only. Which would you rather do?
I think maybe just starting from the beginning.
I think that's a good idea, actually. Since you and I haven't done trig before, I might be able to offer you some tips on how to do these. So let's start off with number 1.
Alright, well, I'm going to go on the
Okay. Number 2. I won't even say anything if it's too easy.
I'm sorry that the phone's cutting off.
Okay.
Okay.
Yeah. Can you read that?
Yeah. So you could say horse B is brown. That be a thing?
Yeah. All horses that run fast are brown, so that if a horse runs... hold on.
Oh, H works.
Yeah, no, you're right. Horse B is brown. No, H does not work, notice. In other words, because all horses that run fast are brown does not mean that all brown horses run fast. Let's say you have brown horses and white horses, and half the white horses run fast, and all, excuse me, no, I'm wrong there. For some reason this question has always bothered me. I get confused on it. I don't know why.
Well, I think I understand that, like, there could be some brown horses that don't run fast, and the horses that do run fast.
Yes, that's what I was trying to say.
Okay.
Okay. So so we good with this one?
Yeah. Weird, but...
All right. What about this one? To find out how much greater it is, we're going to subtract them. When you take x plus 5 and you subtract out x minus 2, what happens to that minus 2?
It becomes positive 7.
Yeah, so 7 is the right answer.
Okay. So 4 times 15 minus 30 is 30?
Yeah. And notice that they kind of attempt to confuse you with all of this huge paragraph here. I mean, if they really just wanted to know what, they could have just said A of B is equal to this. What is A of B when B is 15? Instead, they make it look like it's going to be a tough problem when you first start reading it, and when in actuality, it's quite an easy problem. And they want to do that. They will sometimes give quite a bit of information that is irrelevant to the problem in an attempt really to just kind of confuse you.
All right, so 5 then?
Yeah, number 5.
Okay. I have a question about problems.
Okay.
So normally what I do is I multiply the original starting value by the percentage. So
Okay.
I'm going to multiply 6.6 by 0.2 and then subtract that from the original. But could you multiply it by 0.8?
Yes, you save one step by multiplying it by 0.8. In other words, the way you usually do it is a proper way to do it. You can multiply it by 20% and subtract that. but it is one step faster to merely multiply 6.6 times 0.8, especially if you're able to use a calculator.
Yeah.
Notice the fact that 12 has nothing to do with it. They could have said a carton of soda. So here's a case where they stick in a number that might confuse some people. Okay.
Yeah, I forgot my calculator today.
Oh, okay. Well, you know, I would almost recommend people do that the first time through. That's actually an excellent strategy because you realize how little the calculator is really needed.
Yeah.
You understand that fact. They don't design this test to give people with a calculator a big advantage. In fact, the calculator can lead you astray sometimes. It can make it harder than it would have been had you decided to not use the calculator. So
I kind of wish I had it for like
there's a couple of questions where it's helpful, and including a question like that, because it would be easier if you had a calculator. If you didn't have a calculator, I'd do the 0.2 and then subtract. But because it's hard to multiply 0.8 times that manually, I suppose, harder than it is 0.2 times that. I can do that in my head. So, all right, how about number 6?
Okay, so then you have 8 and 9, so should not be the value. Well, you can't take the square root of negative 7, right? Is that what they're asking?
No, not really. Tell me what the solution to this is. What is A equal to?
8.
It's actually plus or minus.
Oh.
Remember? It's the one thing all of my students have the most trouble with is remembering that plus or minus when you take the square root of an equation.
I'm going to get plus or minus tattooed to the back of my eyelid. I have so much trouble.
And then B is plus or minus 9. So we have lots of combinations. A plus B could be 17. It could be minus 17. What else could it be? What can't it be? I mean, the answer is actually staring at you. If you look at the answers without spending the time to go through the 4 possibilities, you immediately see what it is. Yeah, 100 times bigger than it could ever be.
Yeah.
I guess if you add that number and that number, you get 145. But
It's almost like you want to find out how much common sense you have.
well, it's a lot common sense. It is. It's not just pure math. And in fact, it's very important to understand that the purpose is not to demonstrate how much math you know. The purpose is to get the question right. And they're not always the same. A lot of times you can bypass the math and go straight to the back solving, and that's by far the superior way to do it. And you know, you don't have to show your work here for a teacher or anything. I actually had to learn the California method the other night, if you can believe it. I did. I actually had a student. I picked up an 8th grade student, and they were factoring, and the teacher wanted the student to show the work and show the California method. So oddly enough, I had to have this 8th grade student show me the California method so that I could then help her learn how to use it for factoring. It's really complicated. I know I gave it up many years ago. It's because my method is quicker and simpler, but if they say you have to show the method, I have to learn how to do it, so I did.
Oh yeah, these are just...
Okay. This is actually based on one of the huge principles that they repeatedly test, which is 2 parallel lines and a transversal. When you take 2 parallel lines and cut it with a transversal, you only make 2 angles, A and B. All the other angles there are either A or B. That one's A, that one's B, This one is a big one, so that one's A, that one's A, that's B, and A plus B are supplementary. So a good way to think about it is you create an obtuse and you create an acute angle. And no matter where I'm looking, if A is the obtuse and B is the acute, then I know that that's what it is. In other words, if I want to know what this angle is there, it's acute, it's B. Okay? So here are two parallel lines. Here's our transversal. Forget this other line. Try to block it out. So this is the little angle. Now let me draw it the way they've drawn it. So this is the acute angle. This is the obtuse angle. They are supplementary. So what is that one if this one is 40 degrees?
That one is 140, right?
Uh-huh.
The supplementary is 180.
Yep. And that's pretty much all you need to know about parallel lines with a transversal. That's it. And that will cover a whole lot of questions and problems. There's probably 4 or 5 problems on this test that have to do with parallel lines and transversals. But what they do is they try to confuse you by putting in extra lines like that. Or they might even give you a problem that looks something like this. And they'll give you this angle. And they'll give you this angle, and they'll say, what is this angle? Well, this is a parallel lines with transversal problem. You just have to extend the transversal. And you know that if that's 20, this is 20. If this is 20 and that's 30, this is 130. That's 130. This is 50. So there's lots of variations of the transversal parallel lines, but it really boils down to what I spelled out there. Okay, this is pretty straightforward. Number 8, we might not even need to spend time on these, but...
Yeah, I think 27, I haven't actually done the math, but the other ones seem too low or too high. Is that wrong?
Okay, now let me work through your reasoning again.
So 9 plus 18 minus 18, would it be just 9?
Yeah.
Yeah, it would.
Yeah. You guessed minus 27 first?
Yeah, I didn't see the negative 6. I thought it was a plus 6.
Okay.
So
Okay.
the 18 and the
All right. All right. Yeah. You don't have any problem doing those. That was just a temporary error. Yeah. Don't try to be too fast on those. In other words, you can sometimes, like that other question where we could immediately pick out the 145, those are sometimes unique. You know what this means?
Absolute value, so
Yeah.
bigger than 0.
So if A is 12, what's the absolute value of 1 minus A?
It would be positive 11.
Okay. Number 10.
On the math test, do you ever get questions about like terminology?
No, you don't. You don't, and that's a good thing. That's why I've always liked teaching math by using the ACT. It's not about terminology. It's about being able to do math problems.
All right, excellent.
So number 10.
Okay. So, I don't even know what to say.
Well, after these two statements, what would you do? Just naturally. If you didn't even look at the rest of the question, forget the rest of the question. what would I do if I was inclined to see an equation that said AB equals C and C equals KB?
Then you would say AB is equal to
KB. Yeah, in other words, if AB equals C and KB equals C, then AB has to equal KB. Right?
Yeah.
Okay, now what can I do?
Okay. Now you can divide both sides by B.
Yeah, so A equals K. So J is the right answer. Now, technically you really cannot divide both sides by B, but I don't want to get into that. I guess you can in the sense that they've told you that B is not 0. So you can. That's the reason they put that there. BC is not equal to 0, which means B can't be equal to 0. As long as B cannot be equal to 0, then you can divide both sides by B. If you don't know anything about B, it's dangerous to divide both sides by B there. If 0 is a solution, you will lose it. That's what happens if you divide by a variable that could be 0. You lose the solution 0 if it is a solution.
How would you want to go about possible?
You would subtract KB from both sides, so that the better way to solve this algebraically would be this way. Factor out of B. And now either B is equal to 0 or A minus K is equal to 0. And then when you solve it, you get two solutions. You get either B is equal to 0 or A K is equal to A.
All right.
Okay.
Excellent. All right.
It's kind of like the one I always use. It actually comes in involved with trig also, but if you had a problem like this, x squared equals 6x, you might be inclined to divide both sides by x so that x equals 6, right? But notice, that's not the only solution. 0 is also a solution. So if you do it the proper way, x squared minus 6x equals 0, factor out the x, you get x minus 6. Now either x equals 0 or x equals 6. You get both solutions. Whereas when you divided both sides by x, you lost the solution that x could be equal to 0. Here, let's, got a few minutes left here. X cubed to the 13th power is equivalent to...
Would be 3 times 13, 939?
Number 12. We have 2 over x is greater than or equal to 1/7. What's the largest possible value of x? Now this is a great problem because it demonstrates there's lots of ways to beat this test. One thing you cannot do is cross multiply. You know why?
Because it's greater than or equal to?
Well, yes, and you don't know whether x is a plus or a minus number. So when you cross multiply, sometimes when x is negative, it's going to change that inequality direction. So inequalities are a bit like that last problem where you really shouldn't divide both sides by a variable unless you know it can't be 0. You really shouldn't multiply by a variable when you have an inequality. So we don't want to do this problem that way. This is an excellent problem to back solve. Why? Because we can take their question, what's the largest possible value of x, and I can immediately start testing, starting with the biggest number. Because it wouldn't do any good if I discovered 7 worked. That won't tell me if that's the largest possible. But if I'm looking for the largest possible, let's start with the largest. Is 2/28 greater than 1/7? Is 2/15? Is 2/14? Okay, but we've got an equal. We got a greater than or equal to. I'm sorry, I should have said greater than or equal to. So x equal 14 is our answer. We found it was the biggest number that makes that true. Okay?
Alright, so just in situations where it says largest possible, is it just as a rule a good idea?
No, well, I want you to keep back solving in mind as a way to solve this. There's basically 3 ways to solve these questions. There's the algebraic solution, which we've done on a number of them. There is the back solve solution, which we did on this one specifically. And then the third way is where you can pick numbers and then back solve. And usually that method is reserved where there's variables in the question and there's variables in the answer. Then you can make up a number for that variable and work it out. But back solving is probably the most valuable method to get used to thinking about. We could spend a lot of time on this problem trying to come up with the answer that is a lot longer and harder than back solving. I mean, I guess if we cross multiply, we immediately get this. So, but I'm not sure that that's going to tell me that that's the largest number. So I'd have to play around with it a little bit. And again, it's dangerous to back solve, although in this case you can kind of eliminate the possibility of x being negative, since this is all positive numbers here and we have to be greater than this number. We know x is not negative. So I would be able to get away with cross multiplying here, and I get that immediately. But does that really tell me 14 is my answer? Yeah. It does, but it's not obvious that it tells you that. At least it's not obvious to me. I suppose it might be to other people. But, let's do one more. This is a good one to do, because it demonstrates something. I have a circle that I'm going to divide into 12ths. The circle has a circumference of 46 pi. What's the measurement of 5 of these 12ths? Does the 46 pi have anything to do with the problem?
No, what do you want to start from the middle with 180?
The total around the circle is 360.
Yeah, sorry.
But the reason I said this was a good problem is because it does demonstrate that they stick in irrelevant facts. This 46 pi is meaningless. We don't care what the radius is. That would tell us the radius, but this is one case where the radius is not everything. We know that 360 degrees is completely around the circle, right? It's not 180. 180 is a straight line. So around the whole circle would be 360. So what's the degree of each sector?
360 divided by 12.
Which is 30.
30 degrees?
So what's the measurement of 5 of the sectors?
150.
Uh-huh. Uh-huh.
Okay.
Okay. I will make a note that we got through 13, so the next time we need to work on ACT, we'll know where to begin.
Excellent, okay.
Okay? Have a good one. I'll talk to you on Wednesday. I assume I'm just going to see David for an hour on Wednesday today?
Yeah, I believe so.
Okay. I'm in.
All right.
Yeah. Okay. Talk to you then.
Thanks. Bye.
Bye-bye.